Ocean acidification is the decrease in pH of the oceans due to increasing levels of atmospheric carbon dioxide. This CO2 is being emitted due to many human factors such as gas emissions from various technologies, mainly the burning of fossil fuels, deforestation, and chemicals being dumped or run off into water systems from agricultural fertilizers. Many ocean organisms contain calcium carbonate, which is the compound responsible for building shells in mollusks, coral reefs, crabs, shrimp, and other shelled organisms. This compound is becoming lower in response to increasing CO2. Since these shells are used for protection, these creatures could have lower survival rates. Coral reefs are also important habitats for multiple sea organisms. This makes the fisheries harder to manage because of the change in the environment. In the future, more management systems will be needed to put into place to counteract the changing pH to keep fish and other sea creatures alive. For the first half of the 20th century, scientists thought the excess carbon dioxide from fossil fuel emissions would be taken up by vegetation and absorbed by the immense ocean without accumulating in the atmosphere. Studies that began in the mid-1980s have shown that the concentration of carbon dioxide in the ocean is increasing in parallel with the rise of atmospheric carbon dioxide. At the same time, the pH of the ocean is decreasing, indicating that carbon dioxide levels have exceeded the ocean's natural capacity to buffer pH.
Aquaculture refers to the breeding, rearing, and harvesting of plants and animals in all types of water environments, including ponds, rivers, lakes, and the ocean. The identical factory farm model is being adopted for aquaculture, growing food as cheaply as possible using toxic chemicals and other harmful techniques, packaging it in enormous bulk and shipping it to distant grocery stores and restaurants all around the world. There is a growing demand for seafood worldwide, about a 2.5% increase per year. This is due to the nutritional value of fish being recognized as a primary source of protein and essential nutrients, the need to feed a growing population, and increased income and standard of living. From all-you-can-eat popcorn shrimp at chain restaurants to bite-sized maki rolls at trendy sushi bars to salmon steaks on the backyard barbecue, Americans eat 25% more seafood than they did 20 years ago, an average of 16 pounds a year. Of the 158 million tons of fish produced in 2012, 66.6 million tons were from aquaculture. A report predicts that 62% of food fish will come from aquaculture by 2030, with the fastest supply growth likely to come from tilapia, carp, and catfish. Aquaculture is promoted as a sustainable way to meet rising consumer demand for seafood. However, fish farming relies on small, wild fish to feed farm fish, pollutes the waters around it with waste and chemicals, and threatens wild fish biodiversity through escapes and disease transmission. These are some negative consequences that need to be managed by government regulations and policies. Despite this, aquaculture has the potential to increase global food security in a sustainable manner without overfishing wild populations. Ocean acidification damages not only the natural ocean conditions, but also global fisheries by hindering the ability to produce and manage critical food sources. It is evident that the ocean has lost its ability to buffer pH, and increased ocean acidity is clearly an issue that needs to be addressed by all nations, perhaps through regulations on fossil fuel emissions.